In section 4.2, we're going to be looking at surface area. A surface area is just the area of the surface. So it's one of those words that kind of defines itself. It's the area of all the faces. So when we have a three-dimensional object, we want to find the surface area, okay? And it's the area of all the faces. Now, let's say this. We've been hired to make these fashionable dog steps here that we're going to cover in fabric. Here's our dog steps, okay? And we've got a rise of 4 and a run of 6, okay? So rise of 4, a run of 6 here. So we're going up 4 and over 6, and that's going to be for all the steps. All right, so the question is, two questions. First question, what's the perimeter of the front face? We'll call this the front here. So what's the perimeter of that? Because that's going to be a useful number to us. Well, we've got a bunch of 4s and 6s. And let's see, how many 4s do we have? We have 1, 2, 3, 4, 5, 6. 6 rises. So we have 6 times 4. And then how many 6s do we have? How many runs? All these runs are 6s. And so we have 1, 2, 3, 4, 5, 6. So we have 6 6s. 6 steps, of course. So we're going to add those up. And then this length here is the same as all these 6s put together, right? And this length here is the same of all these 4s, right? The same height. So we can actually just double this now. And that'll give us that whole thing, right? So 6 times 6 is 36. And 4 times 4 is 24. So we have 2 times 24 plus 36. And 24 plus 36 is 60. So that is 120 inches. That's the perimeter of that front face. Okay? All right. So we found the perimeter. Now that's not going to be useful to us in a second. Okay? Now we want to find the total surface area. So we found the perimeter. Now you might want to pause it here. This would be a good one to practice for yourself. Could you find the area of all the faces? We've got this front, and there's going to be one around the back that's going to be the same, right? We've got each of these little rectangles. Okay. And then we've got this big rectangle on the back side. I'll kind of draw it here. And on the bottom, we've got this little rectangle. Now, we got to think about one thing here. There's something that's not given to us, and that's this distance right here. So I'm going to have to give you that distance. We'll say it's 12 inches wide. Okay? 12 inches wide. Let's see if we can compute that. So let's start with the front. Now the area here, we can compute in a couple ways. Do you see some ideas there? You might break it into strips like this and find these areas and add them up. That's a good idea. Okay. We could also, if we're careful and we think carefully, since we know these steps are the same, we could take these two shapes and take this shape here and swing it around over here and put it on top. Up there. See that? That will also give us that would give us a width of an area we not would have. If we put these two pieces together like a puzzle, then it would give us a big rectangle. Can you see that? All right. So it gives us a big rectangle here. All right. And this rectangle would be 3 sixes gives us 18. And then it would be 24. I didn't quite draw this right. It would be a little shorter like this. Okay, because that's this step kind of going up there. So 24, and that's an extra 4 inches. So it's 28 actually, right? Okay. So we want to either use that little little method there, or find the different little rectangles. Okay, that's kind of a tricky one because it's that stair step, but we have 18. What do we end up with here? So the rectangle that we ended up with is 18 by 28. Okay, so the area there, the area of the front, now I gotta be careful. The area of the front is the same as 18 by 28. And that gives us 504. So the front is 504, and so is the back side, which is going to match, just to be kind of a mirror image. Now, what about the carpet that we want to go all the way around the sides? Now, here's a very important understanding that we need to have. If you want to carpet all the way around here, so you want to carpet this rectangle, this rectangle, this rectangle, this rectangle. You could either cut out a whole bunch of rectangles and glue them or sew them all together, right? But if you were building this, you were going to cover this in cloth, you probably wouldn't do that. You would probably take one piece of cloth and you would wrap it around this whole thing. You'd wrap it up and up, over, bend it down, bend it down. Okay, so we could take a long strip of cloth. Here's my long strip of cloth. Ready? Okay. You're going to take a long strip of cloth and you're going to kind of wrap this whole thing around with it. Well, how long would that be? Well, the length of that is the same as the perimeter here. So the length of the fabric we would need is the perimeter. So this is an important concept we're going to use over and over again. The distance all the way around is the perimeter. And so this is what we call the lateral area. We're going to call that the lateral area. Okay, that kind of wraps around. Okay, so the area of the lateral faces is going to be the perimeter times 12. And what was the perimeter? Well, the perimeter was 120 inches. And why 12? Because that was the width. So we have the perimeter times the width. Okay, I'll call that the width in this case. All right. So this is going to be 144 with a 0 on the end of it. Okay, so what is our total area? So our area total, that is the surface area. Well, we have the front and the back, so that's 2 at 504 plus 1440. Okay, and our calculator will, so that's going to give us 2448. 2448, and that's area. Area is in square units. So we have square inches in this case. So the important part there that we're going to use on the next problem here is this idea of these lateral faces. We have these two faces that are the same, the front and the back, and then we have this face, or this strip that we could wrap around the whole thing. Okay. Well, that brings us to this, all right? If we want to find the surface area of a concrete wall, okay, we're going to cover it with a sealer, something like that. We're not going to include the bottom because we're not going to paint or seal the bottom. Okay, so we want the area of all these faces except for this. Now, there's a bunch of rectangles. There's this rectangle on the side here. There's this little tiny rectangle there. There's the rectangle on this side. There's the rectangle on top. And there's some duplicates around there. However, that'd be kind of a lot of rectangles. So let's think of it like this. Think of it like we took a long strip of paper. Okay, we've got this long strip of paper, and we're going to fold it up, over, down, over, down. Okay, as we go around this whole thing right here. Okay, so what would that paper need to be? Or how big would that paper need to be? Well, we have this distance here. We know that this is 16. We basically got to figure out this distance up and over here. What is that length there? Because that length is going to be the height of this paper. This paper is going to be 18 feet long there. We're going to watch our units. Okay? But what does it need to be along there? So, all right, let's figure that out. Well, this length is going to be, we've got the perimeter. We'll call it the perimeter even though we're skipping the bottom. Okay, we're skipping that bottom because it said we're not painting the bottom. So we've got 8, whatever this is, 21, whatever this is, 21, whatever this is, whatever this is. But what are these? I just said whatever 3 times. So what do each of these here have to add up to? Well, they've got to add up to 16, right? Because that little piece, and that piece have to be the same length as 16 when you put them together. So this perimeter we're trying to find is 2 16ths. Plus, we have 8 plus 21. 8 plus 21 is 29, right? So it's 29 going up, and it's going to be 29 going down. So it's going to be 2 times 29. Now, I got to actually fix this here because I just said 2 times 16, but remember we're not doing the bottom. Okay, so I don't need 2 because we're not using the bottom. So 16 plus 2 times 29, well 2 times 29 is 58. So 58 and 16, well that's going to give us 60, 74. Okay. So that's 74 inches. So what that means is we're going to find this lateral face is going to be 74 by 18 feet. We better change that 18 feet to inches so that everything is in inches here. I don't think the directions asked us what to do, 18 inches or feet. And that's going to be 216 inches. So the area here is 74 times 216. So 74 plus 216. I'm going to leave that alone for a second. That's the area around that. But we also need to spray these ends. Okay, so I need to find the area of this upside down T, whatever you want to call this shape here. Kind of looks like an upside down T. And we got 2 rectangles here. This is 8 by 16, right? And this is 21 by, I think it tells us, what does it tell us? Oh yeah, it's 8 inches. So see, we got the 8 inches over here, so it's 8 inches over there. Okay. So that's 8. So this is 21 times 8 times. Okay. So we're going to be calling these the bases because there's 2 of these T's. So the area of these T's are what we'll call the bases. Base doesn't mean bottom, all right? So that's going to give us, we have an 8 times 21, plus we got an 8 times 16. And punching that in the calculator, we get 296 inches. I'm sorry, this is square inches. Okay, so that T, which is the base, because there's 2 of them, bases, will be parallel. We have two bases. They're parallel and congruent. So this is our total area. Whoops. Or our surface area is going to be this 74. Oh, this is 74 times, right? The area of this shape here. Sorry, I messed that up. That should be 74 times 216. That's the area of the lateral faces plus 2 of these t's. So we have plus 2 times this 296. All right, that covers all the pieces. Let's see what the calculator has to say about the actual number. So when we multiply that up, we get 16,576. Now that's square inches. So if we're going to change that into square feet, we can divide that by, so we can take the answer and we'll divide that by 144 square inches in a square foot. So this is 115 square feet. Okay, so we have 115 square feet. And so we can look at the back of our paint or our sealer and see, does it cover 115 square feet? Okay, so there you have it. So these shapes here, mathematically we call these prisms. The reasons why they're prisms is because they have a face on two faces that are exactly the same, like the T's here, and the front and the back of these steps. They're exactly the same, they're parallel and congruent. And then we've got this strip, this lateral face that's wrapped around like we saw there. Okay. So we'll leave it at that and hope that helps there. And find the area of these shapes by finding the bases, the two parallel sides, and the wraparound area there called the lateral face. All right, keep working hard and have a great day.